testing. Okay, recap. We learned previously, just you look into previously. Few vector parameter. The the time differential of your what d s dt. Okay, acceleration will be dv dt, and also because this one is e, we freeze. So we have one equation, two equation, three equation. After that, we derive three Newton equation by using definition of velocity, acceleration, and a ds b dv. We arrive at three Newton equation. When you want to use three Newton equation, remember acceleration must be constant. So the first one, you have v equal to u plus a t. A must be constant. Second one, v squared equal to that replace u with v o. The third one, what is that? V what is that? Delta s equal to u t plus half a t squared. So these are the fifth equation, sixth equation, seventh equation. At least there you score three. Yeah. By erratic motion. So in our when you process meaning that integration to the detail. Like that. It's- Sine graph. Let's say so for dynamics, your question will be 25 marks. Section A, normally you need to draw something. B, you do analysis. Here, normally it's 10 marks. This one will be 15 marks, normally. For the chapter, and B, into another motion, which is longer here. It's actually so every on the circle linear going up in general. In curvilinear motion, in a circle motion, you only need to remember two axes. Every time you see circle, you see curve, you only need to go to the diagram. You can copy and then go to the interest point, go and draw two axes like this. One pointing to the center, one at the tangent. You know what is tangent of circle, right? And the tangent will be 90 degrees from the center. That's called tangent. Okay? And this arrow is depending on whether this object going clockwise or anti-clockwise. If this one go anti-clockwise, then the arrow will showing another direction. Yeah. So there are two important axes, which is tangent and normal, means 90 degrees to the center. So we will conclude this procedure, this circle procedure in today. Okay. So the rest you read lah. The rest you read. The appendix in the canvas, go and download. If you don't know how to vector A dot vector B, how to do, vector A cross vector B, how to do. I assume you already know how to do. So know on how to do. Touch the vector procedure in appendix D. There's an example inside there. Go and read. Yeah, this is your homework. Go and read. Yeah, go and download. If you're expert in okay. So we start, huh? So let's say, too fast. Huh? Okay, now let's say, same, huh? So let's say these particles move in a linear motion. I highlight with the blue color. We consider a path means the where it move, huh? We have a small dot. It move from one location to another location on the curved path. So this no, it means your S is in term, let's say 3t squared plus 2t plus 3 means is move in a function of time. This is a quadratic function. Okay, homework. What is the equation of circle? Go and find. What is the equation to define a circle? Okay, what is the equation? Go and find. This one might be helpful in your test 1, test 2. All the curve will have a center. All the curve will be have its center with from the center to the starting point by r. R is in time function also. Okay. Okay, so this is how you define position. Don't confuse the path and the position. S, the R is position vector. S is a path function. Okay. So for displacement, in a small time of delta t, again, this is the Okay, so the object move from R to R prime. You can define one vector have tail and head. Tail and head. See, there's an arrowhead. Vector is from tail, head. Right? So, so this is a vector form. How you can combine this one, force that you can combine rectangular. So this is equation, how to write the equation of a triangular vector. We try to see vector two continuous vector. This is a means in always have an addition or subtraction. The triangular connected with the tail to arrow. So this is a continuous vector. Vector plus R this is how it, or I take out the F, I just draw A, B, I draw like that. I just label this one C. So this is the starting point, this is the end point. Start point vector to end point will become your resultant force. A will be vector B plus vector C. If you don't know how to write, this is a vector chapter. Okay, now back to the slide here. You see the arrow, you already know how to write the vector in triangular. This is the starting point. This is the end point. So this is a continuous vector. This vector plus this vector equal to this vector. Can write like this. This one, this vector equal to this vector plus this vector. We are vector dimension. So I think this is the first equation for today. R prime equal to R plus delta R. Okay, or you can label this one as A, this one B, this one C. You do in the, you understand whatever that to understand. Okay, so this is the, we come to the curvilinear motion. Okay, you need to build vector every time you see a curve motion. So you need to build your center point. Where does the direction move? Another way, we always like to see our delta. With our delta, or we can remain delta, move our R to the left-hand side. We will get delta equal common presentation. This is called addition. Meaning. Okay. Important, you know how to draw or how to come with this kind of equation, either this one or this one. If you're given a vector, two to draw this one, and then you connect the two dot with the red color or any color. Then write that one as a delta R. Then you see where does it move. Okay. Velocity. You know velocity, we take displacement, differentiate with time. Take this equation, differentiate with time. So, yeah. So it will be delta R, time differential with T. We just need to change this rectilinear S R in rectilinear. Okay. Then because this is delta, we don't like to see delta triangular. We want to change this one into D, something that we can measure. We apply the limb process. Delta T 0, we will arrive at ds dt, right? To limb. Okay, actually it's I put ds here. We assume angle this one is very, very, very small in the radian degree. You learn about the section of the circle in radian form. This is S, this is R. As you know that you arrive at one equation called R equal to S. Sorry, wrong. This is S. S, this is R. Radius, radius, this is a circumference. So S equal to R theta. This is what you learn in the section radian form. In radian form. Every small angle, you can treat this one as straight line. Okay, S equal to R theta. So here, I just write the S here. Okay. And this one is vector. Vector have direction and magnitude. So if you talk about speed, means you need to find the magnitude for this one. Yes. You understand from here to here? Here to here. Okay. You understand why delta R dt? Okay. So because we want to transform the triangular into something that we can measure, we apply the limb law, limb rules. Then if change this one to D, this one also to D. So I put the ds here. It is because when we assume of the section of the circle is very, very small, then previously you learned this S equal to R theta, R theta. So what does it mean? It means that when your R, okay, theta here is very, very small. When theta very, very small, you can assume that S will equal to R. Okay, but this is more mathematical. What is the definition of velocity in the curvilinear? The in the example later. Okay, I just put there just to show you lah. Same with the acceleration. Acceleration means you put this one, differentiate with the t. Same, okay. Before we move on, velocity. How you draw velocity on the curve? For curvilinear motion, remember the green color arrow. This one, this velocity will always tangent to the curve. Velocity, this V will always 90° to the center and is always in tangent direction. I just label sub T just so that you don't confuse with the normal direction. Velocity Vt always appear in chapter 1 or the rest of the question. Velocity that you use for all your calculation will be tangent component velocity. Remember that. They of course they will be Vn here, but for most of your calculation, you are focusing on the tangent direction velocity. Okay, so remember how to draw the green color arrow. So any question that give you a curvilinear motion, you just go to the curve. Let's say this particle move from here to here, from A to B position. You should able to solve the question by starting with axis. There are two axes on the curve. Moving to the center, this is a O. Straight away, you put the O there. O means the center of the curve. Then this direction positive towards the center is normal direction. Then it depends on the motion. In this case, A to B is anti-clockwise. So this is tangent direction positive here. So if this direction is positive, you write the T at that direction. If you write T here means positive in this direction. Okay, so if A to B, it move in this motion, so your velocity, you should able to draw very directly by following the tangent line. This is your V at tangent direction. Of course, there is a normal direction. I don't want to confuse you yet, but important is I highlight the green color arrow. More important. Okay. Then put a V there. Put a V there. Okay, then you. So let's say you have particles move in a velocity at time equal to t, again move in the circular motion. Now, velocity changes. Because you are dealing with vector. The faster you go, longer the thing. But of course, in the test one or your final exam, the same length of the arrow, but different equation here. Because the space you have. Okay, let's say you have a V prime and V. So from here, you actually know that you have two. Call what is acceleration? Et. So actually, you need to find what is the delta V right here, and then you time differentiate it. So how do? You pull the two vector again in the triangular rows. That is the procedure. So I can write something like this because I can build a triangular by V prime equal to V plus delta V. Means if you pull this one over here, you pull V prime over here. Pull V prime. And I pull this one, put at the tail here, I combine the two vector together. Let's say this is V. So, and then the complete triangular must be there. So you complete the triangular. I will just write this one, change of V. How to write the equation of the triangular vector? Again, something must equal to plus 2 vector. On the left-hand side is from start to end vector. So this is start, this is end. So this vector is V prime. So V prime equal to start V plus this delta V, V plus delta V. This is how this equation come from. So there's no drawing on the slide here because we already assume you know how to draw it. Okay. Then we rewrite the equation. Want to use this form, this term. So we move the delta, we fix the delta V, and then we move the V to the left hand side. We get V prime minus V. So we put inside there, we get time differential of your acceleration. In fact, I got put inside the things. Now, my O here is O prime because I pull the two vector away and put somewhere. And I put in the center because this one move in the imaginary curve. And this imaginary curve is called hodograph, but anyway, it's not important. It means hodo means something that you imagine, something that move in a curve. The curve line. Hodo means is something that you imagine or virtual, right? Virtual. So this is a triangular that I draw, same as what I draw on the whiteboard there. It's the same. Okay. So same, we proceed. We get A equal to dV dt. A equal to dV dt. And if you draw on the hodogram, the direction of the vector will be tangent to the hodogram. But this is just for your info. This is for your info. This is only for info. You can ignore this one. So say V can write in the double differential of your displacement. But in this case, because you are curvilinear motion, your S become R. S become R. Your position is the R and not the normal S. Don't focus on circumference. Don't confuse with the circumference. In dynamics, we are focused on the R, the change of R. Okay. So when I redraw the diagram, you know you have to draw the velocity. Velocity always tangent to the curve on the position. Here also tangent to the curve. If you draw center, you will see the arrow also pointing accordingly. Okay. Now in this case, I just highlight acceleration always pointing into the circle. This is the A direction. In normal direction, cannot say in, but there is an acceleration in normal and velocity. But again, just inside the curve. You have AN and AT. You will see AN and AT. Then these two also you need to find the resultant, which normally will give you the resultant to somewhere between the two R and T. This is the resultant and then the angle. Okay? Until later. Important. What is important? It's the yellow color arrow you learn later. And you have seen I, J, K, X, Y, Z, I, J, K, they are U. Means if you write I in your it's moving. I it means the direction is toward y direction. If you write k, means in the z direction. So r, the r dimension. Then automatic, you can write xi plus yj plus zk. So this one also, if you forget how to do, go and flip back your mathematics class, the textbook. Okay, we assume we also know. Okay, means x diagram will give the distance from then j is here to the y is here to here. Okay, this is the y. So you read from the diagram. If this one is 6, then you write 6 here. This is z lah. Z. This is the height. Z you write here. This is a position in vector. You also learn how to find the magnitude, right? Square x is the magnitude. How to find angle? Okay, I'll show you. So this is just a recall. In my slides, I will use both for vector. In your answer, you can use arrow or you can use this arrowhead, or you can use curve in your answer. But anyway, you have come to dynamic already. You don't pay a lot of attention in all this marking. As long as you write I, J, K in answer, I think right. Okay. So to find magnitude, same. You square the x plus square the y plus square the z square root, you get the magnitude of that particular r vector. Direction, we use unit vector. We take the position minus the magnitude. What does it mean? Position is this equation. You take this equation, divide by the magnitude. You get the direction. Yeah. Actually, this one's I pull from the mathematics. Do calculation. So for the direction here, sometimes you already forget. You take the vector divided by the magnitude. If you go to the three-dimensional velocity, you just draw a 90-degree from the center of the curve. Center of the curve. V equal to dr dt. This is just a derivation. You know that dr dt means dx dt. Dx dt is a velocity in x direction. Vy dt, dy dt also velocity in y direction. Dz dt also velocity in z direction. So this is the time differential. Okay, time differential in calculation or cross chain rules, right? Chain rules. Differentiate d dt xi using chain rules means you fix one, you di, you fix one, you dx. This is chain rules. It's called chain rules. So dx dti, dx dti, then x di dt. This is called chain rules. You already forget, just Hain. Chain rules. So you forget, then go and see. So this one, di, I always in this di dt, you get 0. One. Same with the y and z lah. So at the end, we arrive at this one. So the di dt equals 0, dj dt equal to 0, dk dt 0. Arrive at this equation. This one is velocity in x, velocity in y, velocity in z. Given this one, because sometimes if in example, for example, question might give you t plus 6, y equal to 3t plus 3, z equal to 4t plus. We ask you to find velocity in vector form. So dx dt, you get the first one. Dy dt, you get the second one. Dz dt, you get the third one. Okay. Okay. So this is just a derivation. Then you go to the diagram that you draw, you write v equal to what? Vxi plus vyj plus vzk. All this diagram is inside the tutorial question that already in the. To draw all these things, you can download the tutorial question and you open up in your tablet, so you can print it out so that you don't need to copy every time you see. Okay, again, magnitude vector. Can you recall the slide how to find magnitude? 1 plus square this one plus square this one square root. How to get the direction? You take this one divided by this one. The answer was the I, J, and K direction. Yeah. You take this one divided by this is one value. This is still in vector form. You take vector divided by value, you still get a vector answer. Direction was still in the something I plus something J plus something K. This idea lah. Okay. This one I highlight slides. Always 90. Right? You apply the same. Acceleration equal to dv dt. So basically, you just time differential the velocity equation. Then you arrive at dvx dti, dvy dtj, dvz dtk. And then this is just a better presentation. Ax, I, ay, az, and so on. Okay. So far, any question? Can follow. The rest know what happening in this one. You see? So I label the A for you. Okay. So A will be usually inside the curve. This is inside the curve. How you know that inside the curve? Always inside the curve. All right. Okay. Let's say I give you for this curve, where is the center? It will be here. For this curve, where is the center? Will be here. So you need to look at what is the curve. So this center, because this is a polynomial graph. A perfect circle at the center for the curve. Different position. Okay, what else? The rest, same magnitude and direction, still the same. Square, square, square. Take the ijk equation divided by the magnitude. Something I plus something j plus something. Okay. Okay. So I highlight here. In general, because as you learn more and more, you confuse arrow and the green arrow. I go very fast, see if you're able to catch up, then we have a short break. What we learn. And you have a stretchable. So you're given distance, the horizontal position of the weather balloon defined by x equal to 2, but in the time frame. If the equation of the path y, now in y position, you have x squared, y is influenced by x. Determine the magnitude when time equal to 2 seconds. Substitution 2 there in your equation. Derive the general equation. Okay, we start with the velocity. And on the graph here, you know that A to the bottom of B, there is a 4 meter there. So you have y equal to 5x squared. You have x equal to 2p. You know that v equal to dx. You know that v equal to plus dy. We assume doesn't exist or there's no change in your z equation. Z, don't go and become so clever. I believe you can do the derivation. Right now, x no problem. The x dt very fast. What is that? But why? Okay, then you do differentiation. Okay, see. So, equation, you write this equation. You don't need to write the second equation here. You only need to write this one, then apply what you learn. V equal to get 2 unit is 2 meter per second. Okay, 2 meter per second. Or with the blue color arrow, positive to the left, to the right. Have the habit, always you solve dynamic question. At the end, show what is the direction. Or you write positive to the, you just write positive, then arrow pointing to the, okay, either also can. Why you need to substitute, all right? Why you need to substitute? Again, substitute, you know how to do already. The rest is, so from here, you pull the, so you get 8 over 5t is your Vy. So you have two answers. One is 2 meter per second. Z, we assume there's no Z. Okay, means this balloon move in the plane, XY plane. Okay, I put the two answers together. I substitute the value. So at 2 seconds, my velocity is 3.2 meters per second. Velocity is constant all the time. Okay. So again, square. You substitute, you get 377 meters per second. This is magnitude. Direction. Yeah. Okay. A diagram inside the PowerPoint slide. Over here, Vy go up. So the result term will have an angle, right? So, triangular. Square this one equal to the side square, the base square. Triangular rules, right? A, B, C, A square equal to B square plus C square. Okay. Or you can use tangent if you want. Tangent equal to opposite and the side. This is a triangular. You can move this one to here. Okay. Get 58 degree. Once you find that, remember to tell from where. 58 degree from where? From horizontal axis. Here, from horizontal axis. Very fast for acceleration, it's the same. Then we stop the recording. It's the same. You take dv dx. You know that velocity is 2. V equation is 2. You differentiate constant value, get 0. Y also same. But y, you have a t value there. D 8/5t, you get a value, constant value. Unit is meter over second square. So you can get the magnitude. Square root. Okay. So in this case, 0 and 1.0 means what? The x here, the balloon goes up. Okay. So tangent, you get infinity. It happen at 90 degrees. You don't know what is this, go and observe the tangent graph. Yeah. Okay. 10 minutes breaks. We continue 3:05. Okay, 3:05 we continue.